All right, let's get into it for week 4 of 2026. This week, we're talking about something huge. Forget the usual corporate rivalries. The semiconductor industry, it's now a full-blown battleground for entire nations. We're going to break down the massive strategic moves that are basically defining a new kind of technological world war. And really, this quote just says it all, doesn't it? Semiconductors are no longer an industrial sector, but a geopolitical instrument. I mean, that perfectly captures the new reality we're in. The whole game has changed, fundamentally. What used to be just, companies competing against each other has totally escalated. Now it's a global contest for power, for influence, and chips. Chips are the weapon of choice. Yeah, and this bigger game, it even has a name. People are calling it the 2030 war. We're talking about a global technological conflict. And look, this isn't some sci-fi movie, some far-off future thing. No, it is happening right now. Nations are mobilizing everything they've got to try and dominate the next decade of tech. Okay, so what does this new battlefield actually look like? Well, you can think of it as a three-way race for dominance. It's this triangular struggle, and it's being fought everywhere. On the factory floor, deep in the research labs, and absolutely in the halls of government. And this timeline really lays it all out. You can see the parallel ambitions of the key players clear of day. First up, you've got Japan, pouring =1 trillion yen, that's a serious amount of cash, into its Rapidus project. Their goal, an incredibly advanced 1.4 nanometer node by 2030. At the exact same time, the US is pushing hard to get Intel's Silicon Heartland in Ohio up and running for its 14A node. And then there's China, which is making some absolutely critical breakthroughs right now to become completely self-sufficient and get around those US sanctions. So let's zoom in on that Chinese breakthrough for a second, because this is a big deal. They've successfully developed their own high-energy ion implanters. Now, what is that? Think of it like a super precise surgical tool for silicon wafers. It implants ions to change their electrical properties, a process we call doping. By mastering this piece of equipment, they can effectively bypass US sanctions on critical tools from companies like Applied Materials. This is a massive leap for them towards, technological independence. So the main takeaway here is this. These aren't just isolated corporate decisions. Not at all. These are deeply, deeply coordinated national strategies. What we're witnessing is a full-blown, state-led war for technological supremacy. And the stakes couldn't be higher, because whoever wins this race is going to control the future of, pretty much everything, from AI to global defense. All right, now let's get to where the most intense fighting is happening. And that's right at the bleeding edge of manufacturing. We're going to dive into the battle for the 2 nanometer node. This is the next great prize in the world of logic chips. So in one corner, you've got the reigning champ, TSMC. They're planning for just insane 2 nanometer growth, spending a ton of money to do it. But, and this is a big but, they're facing a serious capacity crunch. They literally can't make chips fast enough. So in the other corner, you have Samsung. They're accelerating their own 2 nanometer plans, and they're positioning themselves perfectly to scoop up all that overflow demand from customers who are getting turned away by TSMC. And this just perfectly illustrates Samsung's aggressive push. Their new fab in Taylor, Texas, wow, it's a massive project. We're talking about a critical onshoring of advanced manufacturing right here in the US. They're bringing on 7,000 employees, and they're about to start test operations with EUV, extreme ultraviolet lithography, the absolute top-tier tech, with the goal of hitting full-scale 2 nanometer production in the second half of the year. Oh, and get this. It includes a landmark $16.5 billion deal to make autonomous driving chips for Tesla, right here on American soil. That's huge. You see, this capacity crunch at TSMC is creating a really pivotal moment. The whole market dynamic is shifting. We're hearing reports that 6 major customers are now turning to Samsung instead of waiting for TSMC, or even choosing them over Intel. This isn't just about winning a few orders here and there. No, this is a real, genuine opportunity for Samsung to seriously challenge TSMC's long-held crown. But look, this battle isn't just about the fancy logic chips. The next front in this war is all about memory. DRAM and NAND, the chips that power pretty much everything, from our phones to massive data centers. Control over these has become another massive geopolitical pressure point. And that pressure is being applied, very directly. The US has threatened a staggering 100% tariff on any memory chips that aren't made domestically. 100%! This creates a huge risk for the Korean giants Samsung and SK Hynix, because right now, they don't have those advanced memory fabs in the US. So, in response to all this chaos, the US-based memory maker Micron is making a really bold move. They're dropping $1.8 billion on a deal with Taiwan's Powerchip, or PSMC. Now, here's the clever part. They're not building a brand new fab from scratch, because that takes years. Instead, they're getting immediate access to an existing one. And the goal? To rapidly boost their wafer output by 10 to 15% and get way ahead of these global shortages. So all of this, it raises a really important question, right? As these geopolitical plates are shifting and a potential memory trade war is looming on the horizon, who actually holds the strategic advantage? Who's positioned to win here? Well, the answer, at least for now, seems to be Micron. Here's why. They already have an advanced memory fab footprint right here in the US, which pretty much insulates them from those threatened tariffs. Plus, that super clever deal with PSMC gives them capacity right now, without the long delays of building a new factory. This lets them grab market share while their rivals are stuck trying to navigate all these geopolitical minefields. It's a brilliant move, really. They're leveraging both their domestic presence and their international partners to turn a huge threat into a massive competitive advantage. Okay, so all these incredible advancements in logic and memory, they're all fueling the big AI arms race. But as AI models get exponentially more powerful, a new problem, a new bottleneck, is starting to emerge. And the next front line in this war? It isn't just about the silicon anymore. It's about how you package it. You know, for decades, the back end of chip making, where you slice up the wafer, test the chips, and package them, it was kind of seen as the less glamorous, less important part. All the glory was in the front end, where you actually print the circuits. Well, in the AI era, that idea is completely out the window. Advanced packaging, which is all about stacking and connecting multiple chips together in these complex 3D structures, it's now absolutely critical for performance. And you better believe the arms dealers of the semiconductor world have taken notice. I'm talking about the biggest equipment makers on the planet: ASML, Applied Materials, Lam Research, and Tokyo Electron. All of them are now racing into the advanced packaging market. They're developing a whole new generation of tools specifically to build these incredibly complex chiplets and high-bandwidth memory stacks. So let's break down how this complex dance actually comes together. Think of it in steps. First, you've got ASML's lithography tools printing those super intricate connections. Then, Lam Research comes in and etches those pathways into the silicon. After that, Tokyo Electron handles the really delicate process of bonding and stocking the different chips together. And finally, the Korean firms, who are the leaders here, bond that high-bandwidth memory that gives these AI superchips their incredible horsepower. To win a war like this, you need every single advantage you can get. And that's why companies are starting to rethink chip design at the most fundamental level. So let's talk about the next big weapon in manufacturing, what's being called the curvilinear revolution. Okay, what you're looking at here is a massive, massive leap forward. For the entire history of semiconductors, circuits have been designed with sharp right angles, like a city grid. But now, the industry is moving to entirely curvilinear, or, curvy designs. The best analogy I can think of? It's like going from drawing with an old-school Etch-a-Sketch to painting with a fine-tipped brush. It's that big of a change. So you're probably asking, why make such a radical change now? Well, it's really being driven by the insane computing power of modern GPUs. They can finally handle designing these complex, almost organic-looking shapes. And the benefits are huge. We're talking enhanced production yield, which means more working chips per wafer. And it dramatically reduces the variability between chips, which leads to way better performance and reliability. And here's the kicker. This isn't just some research paper idea. Major players like Micron are already validating this and moving it into actual production. Which kind of brings us to our final thought for the week. All this news, when you put it together, it paints a really clear picture, doesn't it? We're seeing a world that's fracturing into these technological blocks. Each nation is building walls to protect its own supply chain. This race for node supremacy, for memory dominance, for leadership in packaging, it's all driving everyone further apart. But as these walls keep going up, the fundamental question remains. In a world that's increasingly defined by conflict, who is going to build the bridges? The open standards, the new collaborations, the very things that true innovation has always depended on.